the structure basically start with this particular window, which you called as a material properties. So here you have got two things. And shear modulus. If they are constant, that is called as a isotropic material. And for orthotropic material, these values are different. They are not constant. They are not the same one. They are different, right? So that is the basic classification that you should understand. Then comes weight and other things that you already know how to input these parameters. Along with that, there is one more parameter which is there in the this window itself, which is called as nonlinear material data. So here you can put your nonlinear material relationship. But before that, we should understand many things before going for this particular window. But just I wanted to show you most of the things, nonlinear material things are the input started from this particular window where the nonlinear material data can be input. Now, simultaneously, I can show you these windows also along with this demonstration. Just hold on. So I have got this model. So you can define your material from this particular thing. You can see here this graph is also given where you can see the nonlinear graph is given between the stress and strain. So here, if you say this model is actually run, so this is locked actually anyway, but I can show you here, you can show the nonlinear material properties. So this is a nonlinear material data you can import or you can give as an input to the software that we will be discussing
Hello.
in detail.
Excuse me,
Hello?
Prasad. Huh.
Yes, sir. Yes, sir.
The presentation is not visible.
No, actually, I'm showing you this ETAB thing. So I need to share the screen again, right? One second, just hold on.
Huh.
Now I want to share the different window now so that this is visible. One second. I'll just check. Now, how can I share this the different window? Hello.
You can share your screen.
No, but that option is not appearing here. One second. Yes, yes, it is there. Share. The entire screen sharing option is there. I don't know. Yes. Okay. Is it visible now?
Not yet. Screen share option is there. Yes, now it is visible.
Visible, no? Okay. Okay, fine. So, one second.
Some patches are
ETABS.
on the screen.
One second. One second. I will just remove that. Is it clear now?
Yes, now it is clear.
Okay, so that is the nonlinear data you can put into the computer that we will be discussing in detail in our next session. So in this particular section, I will just close this data. So this is the material thing that you need to incorporate or give as an input for the linear modeling. And this is what we call as a nonlinear material data that we will see in detail how to give this data to as a input to the computer model maybe in the next session. Okay. Now let us go back to our to the presentation and just tell me whether it is visible. Now is it visible again? Hello, is it visible now? Presentation?
Yes, yes, it is visible.
Okay. Okay, fine. So now we are actually trying to understand the different parameters associated with input parameter for linear modeling, and in that we have seen this material thing. Now the second important parameter is which type of model or which type of element you should use for your slab element or maybe for wall element. So that is again a confusion. Always there is a confusion between this. So I have shown you these two types of element available in ETABS. One is called as a shell element and another one is a membrane type element. So which one you should use? So you can see here when you say shell, all 6 degrees of freedom are open. That means this particular node, for this particular mode, all three rotations and all three deformations are open. So this node can deform in all three directions. It can rotate in all three directions. So it has got 6 degrees of freedom. So that is for the shell type element. Now, once you say membrane 3 degrees of freedom are locked. It is not used or it is restrained. So what are those? You can see here U3 is not there. U3 is not there. Only U1 and U2 is there. These are the translational degrees of freedom, and then one rotational degree of freedom, that is R3. So when you say membrane, these 2 degrees of freedom are there and only one rotational degree of freedom, that is R3. And but when you say shell, all 6 degrees of freedom are open. What does it mean actually? It means when you lock the third degree of freedom or you restrain the third degree of freedom, your node is unable to deform in that particular direction. And for membrane, it is the third direction, that is the vertical direction. It is unable to deform, it is restrained, or the stiffness is very, very large. Large stiffness is assigned to that particular node so that it will not deform, right? And when you say the rotations, that is R1 and R2 are zero or restrained, that means your particular node is not unable to rotate in a plane, right? So, in short, when you say membrane, your out of plane deformation is restrained. Out of plane deformation is restrained. That means what? Your particular element or a slab is not going to deform like this in out of plane way. It is not going to deform like this. Neither it will translate in vertical direction. So if you use the membrane for your slab modeling, what will happen? This particular element will only able to transfer the load to the corresponding beam. So when you assign a membrane to a slab, the actual stiffness of the slab is not considered in your analysis. And the membrane type slab, what you have assigned to a particular slab, is used only for transfer of load. So it is like a bare frame model. It is like a bare frame model where you are actually transferring the load using area element. So even if, let's say you have got one model where you have not modeled the slab actually, let's say your model is like this three-dimensional model where the slab element is not modeled and you have assigned a load on the beam with the help of UDL. So UDL is assigned on all four beams, but the slab is not modeled. So one model is there where you have modeled the slab using membrane. These two are exactly the same one. These two are exactly the same one. Even if you model your slab with the help of membrane, that is used for transferring the load, not for capturing the stiffness of the slab, right? And in another way, once you call your slab as a shell element, in that case, your stiffness of the slab is also considered. So along with the load, the stiffness is also considered in shell type behavior. So which one is more realistic? The more realistic is shell one. So you should use shell as a slab if you want that your slab stiffness should be captured in your analysis. If you don't want that my slab thickness should not be there in your analysis, then you use membrane type element. Okay, so there is a lot of confusion in this. So in short, the out of plane behavior is captured in shell type element, and in membrane type behavior, out of plane behavior is not captured. That means out of plane stiffness is not assigned to the membrane type element. And here in shell, the out of plane bending stiffness is assigned. Okay, so more realistic one is shell. So you can use the shell element when you want that the stiffness of the slab should be there in your model. So that is the confusion. And where you can do this, you can assign this with the help of software. I will also show you where you can use this to assign. So let's say, let us open a new model first so that I can show you things because this is already run and it is locked. So let us use a new model. It's taking too much of time. Yes. I will just keep this all this thing default. I just wanted to show you all these options right now. Okay, so here when you go for the slab modeling, you have the options like uh, membrane or shell. So if you say add new property, here you can specify the material and all, and here you have the options like shell thin, shell thick, membrane and layer. So here you have to use this shell thin if you want to consider the stiffness of the slab. If you don't want to consider, you can go for membrane. But when this membrane type behavior is used in actual modeling, and when the cell type behavior is used in the actual modeling, generally for all slab you can use this shell element. But for the slabs like your staircase, for the slabs like staircase, where your primary aim is to transfer the load to the adjacent beam, that is our aim. In that case, you can use that as a membrane because it is actually your waist slab, bottom slab of your staircase, which is in an inclined way, and it is not giving any stiffness to that particular floor at the floor level itself. So actually, the stiffness is not our aim in that case. But we want to transfer the load from the staircase to the adjacent beam. So in that case, you can use the membrane one. Okay. Some opening is there, suppose, and you want, and some equipment is installed on that particular opening with the help of some runners. In that case, also you can use this membrane element and transfer the load of that particular equipment to the adjacent beam. So there are many application of membrane element also. Some ramp is there, suppose, in your structure, and the ramp has got in plane stiffness as well as out of plane bending stiffness. But at some location, you need that your ramp only should transfer the load, and stiffness of the bending is not should not be considered. There also you can use the membrane. So there are certain specific applications for using the membrane. Otherwise, you should always go for the shell type element, right? Okay, so let me go back to again to the presentation. So this is the difference between the shell and the membrane one. Okay, now let us go to the meshing type. So there are two, three meshing options which is there in the ETAB. Once you select any floor element or maybe in a wall element, you will get all these options. So mesh at the beam and other meshing lines, then mesh at the vertical edges, then mesh at the grid, visible grid, and further mesh or further divide that element into the number of element having maximum size equal to whatever you specify here. So that this is the option, and this is called as a automation, automatic meshing. So what the program will do is actually he will generate the mesh based on your this input, whichever click you have done in this input. So it will generate the mesh based on this particular input. So which one should be used, so and how much meshing should be the computer time. So you want that your analysis should be fast enough, then use a large mesh or the large size of the elements. Maybe in the range of 3 meter, 2 meter, like that. If you want that my analysis may take the time, that is okay for me, but I want very accurate results. Then in that case, you can refine your mesh. You can use maybe 500 size for the mesh, or even less than that. So your results will be accurate enough. But at the same time, the software, the program will take a lot of time to solve your problem, right? So the meshing, how much meshing should be done? That is again a question here. So which meshing is appropriate? So for that, there is a theory called convergence theory. If you have a time, you can go through that particular literature that is there in the, you can get it from the internet. So convergence theory, what it says is actually, suppose you have got an element like this, and you have mesh it with certain size of the mesh. Okay, so you go on reducing the size of the mesh, go on reducing the size of the mesh. Let us say first, if you assume say 500 size of the mesh, reduce it to 400 reduce it to 300 then maybe 100 50 like that. And the two mesh sizes where your results are same, for the maybe for the beam element or maybe for the slab element, two mesh sizes where your results are same, that should be the size of your mesh. So that is convergence theory in short. Of course it is a very detailed theory. So in short, what it says is, let us say for 400 and for 500 my results are same. In that case, you can use 500 as a mesh size, right? So that will give you the actual size of the mesh, but it takes a lot of time to research the thing. So a general rule, a thumb rule is that your size by default may be 1000 for the buildings up to G plus 10 to 15, maybe up to 15, or even you want that your nonlinear analysis and all these things are there, then you can of course increase this size to 3 meter at least. So for nonlinear analysis, I recommend to go for 3 meter size, because otherwise there will be a lot of elements in your model and it will take considerable time. So 3 meter will be the appropriate size for nonlinear modeling, and for linear modeling you can go with 1 meter size, which is the default one, right? Okay, so that is all about the meshing. And then in the previous version of the ETAB, this constraint option is not there. That means what? You need to match each and every node of your meshing with wall and slab, as you can see here. So this is the requirement previously, maybe in the previous version of the software like SAP and all. Okay, otherwise this will yield into the inappropriate results, right? So nowadays, now the modified version does not require that your mesh should match with the wall. The mesh point should match with the wall. So that is the modification which is done in the software. So there is a zipper element which is introduced here, and with the help of this element, the even if your meshing is not matching, that means the wall mesh and the slab mesh, it will converge into the solution. So the solution will be reasonably accurate, as good as this one, right? Where your meshing is perfectly matching, right? So now you need not to worry about the meshing mismatch between the wall and slab in the latest versions of your software. The next important thing is about the mass source. So that is how you can define actually the mass source. But generally, while defining the mass source, we use only one tick here, which is specified load pattern. And what does the other mean? That we don't know actually. So that I want to explain to you. So it is from the element self mass. That means if you tick this, the element mass is also considered in seismic mass. The element mass means the properties which is assigned to the particular element. With the help of that property, the software will calculate the element mass, and that is used in the analysis as a seismic mass. If you use this option, that is the additional mass option, if there are masses which is assigned to the element in addition to the self weight, that is the element self mass, so that is used for as a mass source. And the third option is a specified load pattern. That means if you have assigned certain load to the structure, that load is used for calculating the seismic mass of the structure. So mass source data, in this you only take this one. This should not be take, otherwise what will happen, this is a dead load which already include the self weight of the structure, the self weight of the various element, because we have given the multiplier while assigning the load to the one. For a dead load multiplier we have given it one. That's why this is already considered. So if you take this, suppose if I take this, what will happen, the dead load, the self weight is again added to the dead load. So it is actually doubling the load, dead load, if you take this. So it should be unticked. Okay, and then only option, if you are using the load pattern to specify your mass source, the only option you should take is this one. And then you can specify this load pattern as per your IS code. That means the 50% of the live load when your live load intensity is more than 3 kilonewton, and 25% of the live load when it is up to 3 kilonewton. One more thing you should remember, that the roof mass should be zero while calculating the seismic mass of the structure. That means what? Where the IS code requires that the whatever load, that is the mass of the structure, roof live load, that should not be included in this particular mass source. So for that, how will you do that? Suppose you have got a building and all loads are defined in the live load case. That may not be appropriate, because in that case, when you assign this multiplier to a particular live load, the roof live load is also considered in your mass source. That we don't want. So it is better to assign a separate load case, for which is also called as RLL case, that is roof live load case, and assign your live load, top roof live load, in this particular case, so that you cannot include this in this mass multiplier, right, to calculate the seismic mass of the structure. So then you can only include dead load. Dead load, of course, it has got many dead loads, maybe superimposed dead load, wall load. You can make number of cases if you want in the dead load case, and that is included with one factor. That means the entire dead load is considered, and the live load with the appropriate factor as per IS code, and then you can add one more load case which is roof live load, and which should not be considered here. And in that way we can neglect this roof live load, which is the requirement of your IS code, right? Then there are three options here. Include lateral mass, include vertical mass, and lump lateral mass at story level. What does it mean? Include lateral mass means the translational masses in X and Y direction and rotational mass in Z direction is assigned. That is the appropriate option for us. So we need to include the translational masses because we are carrying out the lateral load analysis here. And we want that our masses should be lumped at the story level. That means what? If your building is like this, and if there are number of stories, all masses are lumped at the story level only. So it will represent some multi-degree of freedom system actually. So masses are lumped at the story level that we want. Along with that, now suppose what it will do, why this option is there in the ETAB, because we are actually analyzing this as a multi-degree of freedom system, and it is obvious that the masses are lumped at the story level, but still this option is there. That means what? Suppose there is a mezzanine floor somewhere in between the story. Let's say there is a mezzanine floor. So in that case, this is a mezzanine. So for this mezzanine, actually ETAB doesn't know where to lump the mass of the mezzanine floor. Okay, so for that, this information is required for the software. Otherwise, the software will generally neglect this particular mass. Okay, so lump masses at story level means what ETAB will do, if there is a mezzanine level, it will calculate the mass of this particular seismic mass of this mezzanine layer, and it will lump that mass, or it will assign that mass to the nearest story. Suppose, let's say the mezzanine, here the story to story height is, let's say, for example, let's say 4 meter, and then mezzanine is modeled at, let's say, 1.5 meter between from this particular story. So what ETAB will do, it will calculate the mass at mezzanine level, and that mass is assigned to this particular story because it is the nearest one, right? Which is at 1.5 meter from the mezzanine, right? Not to the this story. Okay, so that's why this option is there in the ETAB, right? So you should use this option. You should take this option if you have got mezzanines. If mezzanines are not there, even if you take or you don't take this, the results will be same. Correct. And what does it mean, the vertical mass? If you are doing the vertical analysis, seismic analysis, then you should include this vertical translational mass also. So for the earthquake effect, where you want to consider the vertical acceleration or vertical earthquake effect, there you should include this vertical mass. Otherwise, the lateral mass are enough. And then lumped mass at lateral level, that option is enough. So this is about the mass source. And here, I think you know where this option is there in ETAB. So I will not go into the ETAB again because this is the same window which is shown over here. Okay, now the next very important thing is about diaphragm. So why we need the diaphragm actually in ETAP? That is again a question most of the software users does not understand why we